How are you? Hope you are doing good. So today we are going to discuss one more lecture of surface area and volume. That is the lecture number 5. Last lecture of this topic. So let me start with uh, just a moment. Uh, yeah. Yes, I think this is visible now. Okay. So as per this is a very important topic, and weightage of this topic is also very good. So let me start with it has near about 7 marks in your boards. Fine. So let's start. See, today we have to discuss about the embankment related problems and the rate of flow. See, sometimes the rate of flow, the volume, you see there is a cylindrical pipe, right? Okay. And the volume flow through it in the some other container, let us suppose the cuboid. Okay. You put the in any other form, right? That's collected in the cuboid or in the conical vessel like that. So these problems we have to discuss. Fine. Now the next thing is embankment related problems. Suppose you have a well. Okay. The mud that is taken out, that is used to find that is used to make the embankment around it. Okay. These type of problems that we have to discuss today, right? Okay. So let us suppose this is the embankment which is around the well. You have seen these kind of questions as well. Okay. Now see, let's see the working rule in it. Rate of the flow. See, whenever the rate of flow you need to talk about, so first thing that comes in your mind, that is the rate of flow, that's the speed. Okay. Now speed is equal to distance divided by time taken, isn't it? Now, if I take this time as a unity, that means 1 second, 1 minute, 1 hour. So, can I say this speed will be equal to the distance? So, remember, this is the most important thing. The amount of the water flowing through the pipe per unit per second per hour is actually equal to the height of the pipe. So, this is the main thing that I was trying to just show you, that this is the main working rule in it. Okay, is that thing clear? And remember to calculate the units should be, all the units should be same. Sometimes if you are working for the centimeter, you need to convert all of them into centimeter. If you are going to calculate for the this uh, kilometer, you need to convert all of them into the kilometer. So same is the question. Okay. This is the first question. So first of all, what is the question saying to us? The question is saying that uh, see, the cylindrical pipe has an inner diameter, it is 7 centimeter. Okay. 7 centimeter, if it is the inner diameter, so can you tell me what will be the radius? Radius will be 7 by 2, that is equal to 3.5 centimeter. Right? Okay. Now the volume of a water flow in the sea. Now what you need to do, you need to find out what is the volume of a water flow per unit time is in a minute it flows this. Okay. So volume of flow in 1 minute, that is equal to 192.5 liters, isn't it? Now what can you say about find the volume of a rate in kilometer per hour? Okay, first of all, let me take it in 1 hour. Okay, so it is in liters. I will take it change it into centimeter cube. Okay, so this will be 192.5. First of all, I will change it in the hours multiplied by 60, then centimeter cube, that is equal to 1000. Let's put it as it is. Okay, okay. Now, see, find the rate of flow in one this per kilometer per hour. Okay, now let us suppose let h be distance covered in 1 hour, isn't it? If the distance, so same is the case. So h is the distance covered in 1 hour. So what we need to do, we need to find its flow in per hour. So that is actually its height. Okay, so one and the same thing. That's actually what we are trying to find out. So its volume will be pi r square h, isn't it? That is pi into 3.5 whole square into h. Okay, now you see this volume is actually equal to the volume that is here in this per hour. So that is pi 3.5 whole square multiplied by h is equal to 192.5 multiplied by 60 into 1000, right? So you will get here h is equal to 3 centimeters. So I think this is equal to 3 kilometers, isn't it? So that is equal to 3 kilometers. Now this is your length. Now, as I have told by the previous argument, the same as the length, the same will be speed per unit time. Okay. Now it is in the 1 hour. So I was calculating for 1 hour. So rate will be 3 kilometers per hour. This is your answer. Okay, I hope this thing is clear to you. Fine. Now let's go to this is the solution of this question. Okay, fine. Now let's move to the next problem. That is the embankment related problem. See, whatever the earth is taken out. Okay, so here the main issue, main focus is that the volume of well is equal to volume of embankment. Embankment means whatever it is outside, and its volume is, let us suppose it is r. Okay, let us suppose the volume of outer is r, so this is pi r square, since the height is same, minus pi r square h. This is outer and this is inner. Okay, this can be also written as pi h r square minus r square. This can be also used. Okay, this is the main thing that you need to about the embankment related problems. So first of all, let's start with this problem. What is given? What is given? Okay, a diameter with the diameter has a well whose diameter is 7 meter. So it is radius will be 3.5, isn't it? Okay, and its height is, that is its long is 22.5 meter. Okay, the earth dugout is used in the form of an embankment. If the height of the embankment is 1.5, so you need to find the width of the embankment. So let width be x. So what will be the outer radius? Outer radius will be r plus x. Oh, sorry, r is equal to inner radius plus width, isn't it? Isn't it? So this will be your outer radius. Fine. Now, what is the volume of? So what is the thing that I need to discuss here? That is the volume of well is equal to volume of embankment. What is the volume of well? Pi r square h. Okay. What's h? 22.5. Okay. Okay. Wait. Okay. Fine. Now this thing is equal to volume of an embankment. What is the volume of an embankment? I told you right now. What is the volume of an embankment? That is pi r square into h. What is h? Height of the embankment. That is 1.5. Okay. And inside you have r. What is the r? Outer radius. R square. That is 3.5 plus x whole square minus 3.5 whole square. Okay. Now pi and pi will be cancelled. Now, after solving this thing, you can get it easily. So this will be, mm, you can see this is equal to 3.5 whole square multiplied by 22.5 whole divided by 1.5. This thing is equal to 3.5 whole square plus x square minus 2 into 3.5 of x minus 3.5 whole square. This and this will be cancelled. This will be 7. And all the things after calculating this, I will get x as equal to 10.5 centimeter. So this is the width. Okay. If I need to find the outer radius, so this will be inner radius, that is 3.5 plus the outer radius. You will get the answer as whatever it is. Fine. Is that thing clear? Now, this is the solution of this question. Fine. We can check it. Now, again, one more question. What do you need to do? A well is 3 meter in deep and diameter 3 meter. So what will be its radius? Can I say it will be 3 by 2 centimeter? And its height is equal to 14 meters. So it will be equal to 14 meter in height for the well. A earth is taken out and spread evenly in the form of a rectangular circular ring with the width 4 meter. Okay. So if R is this, what will be the outer R? 4 plus inner radius, because 4 is width, that and that is this. Are you getting me or not? So this will be equal to 11.2 centimeter. And form an embankment. You have to find the height of the embankment. Simple question. Simple question. So how it is given? Volume of, what is the volume of well? Volume of well is equal to volume of embankment. Okay. What is the volume of well? Pi r square, that is 3 by 2 whole square, into h, that's 4 square. Oh, sorry, it is 14. Okay, 14 square. This thing will be equal to, yes, this is equal to pi r square. What is r square? Pi into h. What is h? Height of the embankment. I don't know. What is it? Okay, let us suppose this is h1. Multiply, divide it into outer radius, that is 11 by 2 whole square, minus inner radius, that is 3 by 2 whole square. Right? This and this will be cancelled. Are you getting my point? Okay, this will be 9 by 4. Oh, sorry, this is not 14 square. 9 by 4 into 14. This thing is equal to h. This will be 121 divided by 4 minus 9 divided by 4. Right? So this will be 112 divided by 4. So I will write it here. So this will be equal to h will be equal to uh, 9 by 2 into 14 multiplied by 4 whole divided by 112. I think this is the because this will give me h into 112 divided by 4. This 4 will be on that side. This 4 will be on that side. So after computing, what I will get, I think I should get uh, 14 into 8 is 112. Okay, so it is 1.125 meter. So I think this is the height of the embankment. Yes, this is the answer. Okay, so you can see this is the answer of the question. Fine. See what I have done, the outer minus inner multiplied by height. Height is taken on the other side. So after getting all this equation, I got this. This is the answer. Fine. Oh, these are the three problems that you need to discuss. See, rate is given. Okay, rate is given, internal radius is given, and the diameter is given. How much time? See, first of all, you will find the time for the 1 hour. Okay, volume in the 1 hour. Now you will find the circular system, how much volume it can take. Divide the both things. Okay, same is to be done for this, same is to be done for this, right? Okay, now check it out, and these are the solutions of these questions. Try to do it. Okay, okay, take care. Bye.